Hi, good morning. Today I am going to take about computational intelligence tools and role of computational intelligence tools, how this will helpful for medical diagnosis field, for clinical decision making. So today, and I'm just cover up what are the components of computational intelligence and what are the components of soft computing, how this can be applied to the real-time application. So the outline of this topic is what is computational intelligence, components of computational intelligence, what are the tools and techniques used for computational intelligence, and what is the role of the soft computing components, mainly neural network, fuzzy logic, genetic algorithm, how these techniques can be applied for diagnosis and prognosis of particular disease, etc. Let me start with the introduction. What is computational intelligence? Intelligence, in general speaking, is the ability to do the right thing or best thing to achieve a goal. Humans and some animals exhibit intelligence, but what about computer? Do the computer have intelligence? No. We need to inject intelligence to the computer. That is called computational intelligence. Are we going to model the human brain? No. See, computational intelligence means like we are making the computer ability of or capability of the computer to exhibit intelligence. For example, somebody has developed a robot for picking up an object, that is exhibiting some of the intelligence. For that we need to program. A machine which plays chess, that is also exhibiting the intelligence. Some computer answers for natural language NLP questions, that is also exhibiting the computer. How is it possible? Through we are injecting the intelligence to the computer. So how to make computers intelligence? Should we model human intelligence? Yeah, it's a good idea, but the thing is it's difficult to model because our human brain is different from computer processor. Humans are very good in remembering, recognizing the patterns, but what about the computer? It's good in crunching the numbers. But now in this era we have to make most of the application, most of the corporate sectors, most of the human being are replaced by the robot. So it start exhibiting it start think about human being, think like a human being. So a compromising approach, we need to use the capability of the computer, at the same time we have to make the computer to simulate the human brain. So that model the human intelligence, we need to model the human intelligence as much as possible. At the same time we need to use the ability of the crunching numbers. It's very good in crunching numbers. So that advantage also we need. For example, aeroplanes have wings. It has wings like birds, but do they flop? No, it will not flop. We have to, that should be engine should be programmed to flop. Even though it looks like a bird, it doesn't do itself. We need to program, or the engine should make to fly. This is the technology. So what are the components of computational intelligence? Mainly this computational intelligence, what it does, it just turning the data into knowledge. This is a major challenge, how to turn the data into knowledge. Lot of tools are available, all the data mining, soft computing, most of the people are working because every minute people are producing lot of data through Facebook, through email, through chatting. Every human being, every living organism, they are producing the data for every second. How the data can be converted into knowledge, that is the biggest challenge in this era. So for that, the tools like computer intelligence tool, artificial intelligence tools are very much helpful. So these are the components of computational intelligence tools: fuzzy logic, neural network, evolutionary algorithm, expert system, multivariate analysis, pattern recognition, and visualization. And each and every tool has its own purpose. For example, if you take fuzzy logic, this fuzzy logic is good at representing the knowledge. If you take neural network, it is good at learning. It's mainly for machine learning. It will learn like a human being. And evolutionary algorithm, it's good as optimization. Like for each and every component, there is a purpose. And our focus is like fuzzy logic and neural network genetic algorithm comes under soft computing. So these three are the mainly used in the medical domain. So before getting into the topic, let me define what is computational intelligence. It is concerned with solving effectively non-algorithmic problems. It's concerned with solving non-algorithmic problems. What is non-algorithmic? What is algorithmic first? See, suppose if you want to add two numbers, what you have to do? You have to give input, you have to add, then you have to display or print. For example, input A, input B, C equal to A plus B, print C. This is algorithm. Because here you cannot skip any step. It should go step 1, step 2, step 3, step 4. This is algorithmic way. For a lot of traditional computation, all they are doing in this way. But computational intelligence is concerned with, it solves non-algorithmic problem. That means, like human being, it's able to recognize. See, from childhood, if we see any object with the 4 legs and one top, we say it is a table. The same way we are making the computer to recognize the things, to recognize the pattern. That is called computational intelligence. So the computational intelligence mainly it correspond to all cognitive process, that is like perception, observation, perception level, it works. Whereas artificial intelligence, this is also part of computational intelligence, but the thing is, it also solves non-algorithmic problem, but the mode of operation is different. Whereas artificial intelligence, it requires systematic reasoning and symbolic knowledge representation. Roughly, this is somewhat higher level. This computational intelligence is in the lower level. This somewhat high level. Roughly, this corresponds to high level cognitive process. So CA is a low level cognitive process, and AA is a high level cognitive process. So what should CI methods do? As I discussed earlier, what should CI methods do? What are the things? It has a lot of components. Every component has its own purpose. One component will help to model the data. The model can be descriptive model or it can be predictive model. And it allows to classify the data, approximate the data, find the relationship between the data, what are how the data are stored or how the data are associated each other. So it can be used for associate, correlate and complete the pattern. Sometimes for particular application, if you need to discover a new pattern or new trend, that is also possible with the help of computational intelligence tool. At the same time, with the help of visualization, you can easily visualize multi-dimensional relationship among the data. So it is finally it helps us to understand the data clearly, what is what and how the data are associated, related, how it could be, how the inputs and outputs are mapped. With this, with the help of computational intelligence, it can be easily possible. At the same time, it is also helpful to create an expert system. Suppose if you model the data, if you apply that model for particular applications, and after some time, if it works well, after some time that model can be treated as expert system that can be used anywhere, like how the embedded system or how the intelligence, like when in the car, if you take high-end car, the intelligent systems are incorporated in the dashboard, how it behaves. So once if you design, if it works well, it can be treated as an expert system. So what is clinical decision support? So the area of the topic of interest is actually how these techniques are used for clinical decision support. So I just want to say a few lines about clinical decision support. What is that? Clinical decision support. See, a combination of different knowledges. If you want to make a decision for any clinical problems or for any disease, we need to have before taking the decision 3 types of knowledge. One is knowledge from the textbook materials, what are the books, what are the CDs, web sources or internet sources, what are the sources available, you can gain knowledge from there. Or expert knowledge, doctors, clinicians knowledge, or gained experience from learning and individual and from individual patients. We are here in the third level. Our intelligence tools place in the third level. So before getting into neural network, let me say what are the, let me give a little brief about the what are the different computing technologies available. In general, there are two problem solving technologies. One is hard computing, second one is soft computing. Hard computing, it always deals with the precise model. There should be discrete input, there should be strong boundaries 0 and 1. So it is also help to solve the problem, whereas soft computing is also helping to solve the problem. But the thing is, hard computing, for the input, actually we need to, it is able to create a precise model, and this is totally traditional numeric model. It can be either, if you have data, it can be model either numerical model or analytical model, and it plays based on the logical reasoning. As I said before, hard computing, artificial intelligence is a hard computing. You know why it is hard computing? It is also solve the non-algorithmic problem, but the thing is, it requires symbolic knowledge representation as well as reasoning. The same thing here. It can be modeled as a precise model. Whereas soft computing is approximation. You cannot find correct answer for any, if you solve any problem, because soft computing is mainly used for solving the complex problem. So if you want to solve the complex problem, you will not get a correct answer. It converges towards a solution. It's not like 0 and 1, you can't. It converges towards the solution. That's why it's called approximation. So it is very good in functional approximation. That's why we say it's approximate reasoning. And it is here in hard computing, it uses the traditional search technique. If you want to, if a set of solutions are given, traditional search techniques. Whereas soft computing, it uses randomized search. So for that, one of the beautiful techniques are available, that is called genetic algorithm. Our focus is in soft computing. What is that? It is nothing but a symbiotic use of many emerging problem solving discipline. If you put all this discipline together, you will get this soft computing. The main component of soft computing is, we say, 3: neural network, genetic algorithm and fuzzy logic. According to Professor Jada, is defining soft computing as, in contrast to traditional computing, it exploits, soft computing exploits the tolerance for imprecision, uncertainty and partial truth to achieve tractability, robustness, low cost solutions and better rapport with the reality. What does it mean? See, when you define soft computing, here for soft computing, even it will works with the noisy data also. No need to do all pre-processing. You need to do when you give input to the any soft computing technique. Pre-processing is required, but it works with the noisy data. It works with any kind of the data that is defined here. It is exploit tolerance for imprecision, not precise data. Uncertainty, something you can't predict, that is uncertainty, and partial truth to achieve even it will work with the partial truth data. Robustness, low solution cost and better rapport with the real-time applications. That's why it is given reality. So let us narrow down all these 3 topics: artificial neural networks, genetic algorithm, fuzzy logic. So artificial neural network it's good for learning. It will learn like a human being. It's machine for learning, and it function approximation with the noise. As I said, function approximation with the noise. It provides solutions with the noisy data. And genetic algorithm, this algorithm is mainly used for reinforced search and for optimization. And fuzzy logic algorithms dealing with the imprecision and uncertainty. This fuzzy system is mainly, it's meant for knowledge representation. This is knowledge representation, that is artificial neural network is learning, whereas genetic algorithm is for optimization. If you put all these 3 techniques together, you will get a solution for any kind of problem, real-time problem. So there is a comparison between expert system. Expert system is somewhat after developing a model. If the model works for a particular set of data, that can be considered as the expert system. expert system, fuzzy system, neural network, genetic algorithm. There is a small comparison between all the 4 techniques. Whereas neural network holds good in a lot of activities like uncertainty, imprecision, adaptability, learning ability, knowledge discovery and maintainability. Whereas genetic algorithm is good in uncertainty, imprecision, adaptability and learning ability. Whereas fuzzy system holds good in knowledge representation, uncertainty, imprecision, explanation ability. Expert system is good in explanation. If you want to put the data, if you want to represent the data through expert system, it's easily possible because it has a provision for explanation. Explanation ability is there. What do this method do? As I said before, it just provide a models. All these techniques will help to model the data. The model, it is not necessary it should be parametric model, it's all non-parametric model. And this, using this model we can classify the data, we can cluster the data, we can find the association between the input output, we can correlate the data. Through this, what the output of this thing is, this can be helpful. What are the things, association, clustering, which will help prediction, will help for diagnosis and prognosis. So it is allowed to discover the new pattern or new category, and through fuzzy logic you can create a fuzzy rule, you can create a data set, and through multivariate analysis you can find out the multi-dimensional relationship. This is various forms of health data. Health, what is that? This is many other forms, how the health sector, how these companies are playing. These companies are playing major role in the health sector. Google Earth, M-Health, telemedicine, all these things. Then why clinical decision support system is required? What it does in hospital? It's maintaining clinical records, maintaining patients' records, follow preventive care, and monitoring the medication orders, avoiding duplicate unnecessary tests, and assisting clinicians. This part is our major role with the proper diagnosis, treatment, keeping a track based on knowledge base. So in India, in most of the companies in a hospital like Apollo Corporate Hospital, they started using this CDSS tool. So now most of the data are available in the cloud in the form of electronic health record, which will help to solve many epidemic disease problem through this. So I will come to the point again. Neural network. What is artificial neural network? What is that? It's as I said before, it's for learning. It's a kind of machine learning. How it works? How artificial network works? Whether artificial neural network is hardware or software? No, it's neither. It's hardware. If you say hardware, it's hardware. If you say software, it's software. What it does? It just simulate the behavior of biological nervous system. It is artificial neural network is behavior of it. Just simulate the behavior of biological nervous system. It is composed of lot of interconnected neurons. A lot of neurons will be there. They are interconnected each other, and it will work together to solve a particular problem. So, it thinks like a human being. So, artificial neural network, like people, it learn by example. So, artificial neural networks, like people, it can learn by example. If we see, if anything is four legs, one top, means we say table. If it is 4 legs, 1 top, 1 back, means it is a chair. Like this, artificial neural network, by giving input, by training the network, it automatically learn like a human being. And most important ability of artificial network is its ability to learn from the data. Learn from the data, thus potential, and with this ability it is able to generalize or able to predict the future. So it is able to give the acceptable output for unseen input. Suppose if you have a data set, if you train the neural network with any by giving 5 parameters, 4 leg and 1 top, if you keep on giving this input, if you train the system, then the output is table. If you learn after 500 iteration, if you give any input, it will automatically say it is a table. So it's a potential to generalize the things, which is very important for this ability is very important for prediction task. So neural network are well suited to tackle the problems where the human being are being used to tackle the problem. Wherever the human being are able to make a decision, there you can replace by artificial networks. So it good at solving like prediction and pattern recognition. And it is apart from that, not only prediction, and apart from that it is able to derive the meaning from the data. So one of the main component of CI is turning the data into knowledge. So from the noisy data, this neural network is able to derive the meaning and can be used to extract the pattern and detect the trends that are too complex to be noticed by the human being. Sometimes some of the patterns even by human being, by seeing, they can't identify. That can be easily, once a trained neural network able to identify or able to detect the pattern which is not being seen by the humans. So a trained neural network can be thought of expert in the category of the information it has been given to analyze. If you use one neural network for stock market prediction, after sometimes it can be called as neural network, stock market controller or expert system, stock market expert system. It can work. It will be work for the particular application. The same cannot be used for medical diagnosis. If you train for stock market prediction, that can be used for only for stock market prediction. If you train neural network for diagnosis or for prediction of a particular disease, it will be used only for that purpose. So once the trained neural network, it can call expert system. So this expert then can be used to provide projections and new situation. Once the expert is, suppose in future, if any different kind of data or any indifferent data if you give, then it will be able to give a new projections, or it will be able to give a new predictions in that area. So similar to biological brain, neural networks capacity to learn, memorize and create a relationship among the data. That's it. It's able to learn, memorize, like human being able to learn, memorize and create a relationship among the data. So how it will work, the functionality depends upon neuron weights and the architecture. So each neuron is connected each other. So each neuron, for each neuron is connected each other, each link it has a weight. There is a weight. It depends upon the value of weight. It works. And how many layers? It's a layered architecture. A neural network in general it comes with the 3 layers. There will be one input layer, one hidden layer, one output layer. But apart from that, 2-3 hidden layers are there. It's a layered architecture. So depends upon the nature of the problem, depends upon the application. You can have any number of neurons, any number of layers, and the connection weight between the neurons. So each neuron, technically we say processing unit. Each neuron is called processing unit. So the processing unit, another name for processing unit according to that author Mikula and Pitts, it's a perceptron. We say perceptron. What it does, perceptron? It's a kind of the perceptron. It takes input, and each input is weighted inputs. The sum of the weighted inputs, if it is greater than threshold, the neuron fires or neuron triggers. Then the data will be sent to the next neuron. The data will be passed to the next neuron. So perceptron calculate the weighted sum of inputs and compare its threshold. If sum is greater than 1, the output is set to 1. Otherwise, output is set to -1 or 0. See here, look at this diagram. Here x1, x2, xn are the inputs. Each input is like is weighted. W1, W2, Wn are the weight of that link. Apart from that, we are giving the bias. Why? What is the necessity to give bias? To converge into the solutions. Here bias input is 1, and every processing unit, it has an activation functions. After getting the input through activation functions, it produces output. The output is greater than threshold, this neuron fires or neuron triggers, otherwise it will be 0, the output will be 0. So like lot of activation functions are available. One is step function, second one is sine function, and third one is sigmoid function. Step function, what are the inputs you are giving to these neurons, it will be passed as it is. That is linear threshold unit. Step x equal to 1 if x is greater than equal to threshold. It is 0 if it is less than threshold. Whereas sine function, instead of 1 and minus 1, it uses a sign plus 1 or minus. If it is less than 0, minus 1. If it is greater than 0, it is plus 1. And sigmoid functions, it is 1 by 1 plus e power minus x. This is most of the algorithms, most of the applications, it uses the sigmoid functions, because you cannot fix up with the two boundaries 0 and 1. It can be like integration, it can be, it varies from 0 to 1. That's why most of the activation function, most of the application we use sigmoid function. So this is a architecture. Generally it comes, this is, we say feed forward multi-layer perceptron or feed forward neural network. It has one input layer, hidden layer, output layer. The input will be given to the input layer. From the input layer it goes to the output layer, then goes to the hidden layer, then finally output layer. See, for every neural network, like output, there will be one actual output and desired output. See, suppose here there are different types of learning. It will, and the output layer, what is the target output, what is the actual output? It will compare if it is, if there is a difference, then it can be called as error. That we will discuss later. As of now, you just understand what are three layers. This is input layer, hidden layer, output layer. Input layer takes input, then the hidden layer, why we should have hidden layer here? Actually we are converging towards the solutions. We are training the network. See, we are training by giving input, by modifying the weight, we keep on training the network in order to achieve, in order to reach the solutions. For that we have hidden layer. So there are two types of learnings mainly here. One is supervised and third learning is there, but we focus on only two learning. One is supervised learning, another one is unsupervised learning. Because learning, turning, we need to train, we need to make the neural network to think like a human being. So we need to train the neural network. So one is supervised training or supervised learning, second one is unsupervised. In supervised training, what we say, we know the input. For this input, suppose if there is a one top and four leg, we know it is a table. If anything, four legs, one top, one back, then it is chair. So we know input as well as we know output. So here during supervised learning, both the inputs and outputs are presented to the neural network. So we are training the neural network in order to such that if it is four legs and one top, it is a table. Four legs, one top and one back, then it is a chair. It should give the output. Until then we are training the neural network. That is called supervised learning. So supervised learning, like supervised now in front of teachers, how they are being given training. So we are training the system by providing both inputs and outputs together. Unsupervised, only inputs. After training the system, it will behave like an expert system. Okay, it will start predicting the things correctly. Then if you give any input, then automatically it will give the whether it is chair or table or whatever may be. So it will give that output. That is called unsupervised learning. So unsupervised learning, only inputs are given, outputs will not be given. Inputs are given, based on the input it will just predict the output, or it will classify them. So in training phase, what actually training, in order to train the neural network, we should have large number of datas. One or two datas are not enough. The training set is, it should be more than hundreds. It should be in numbers, 100 in numbers, because the training data set is generally divided into two: training set, validation set, test set. Because training set, it's totally supervised learning. Test set, it is unsupervised learning. So when you train the system, it will start learning things. One time if you say that any kid, this is a table, he or she will not understand. You keep on saying, this is a window, this is a curtain, you keep on teaching them. The same way neural network also, you keep on training them, then it will automatically start learning. And too much learning also, too much, if you start memorizing the things too much, that will also create another problem, that is called overfitting. For that we have another technique to solve the overfitting also. See, mainly here neural network, it uses a back propagation algorithm. What is back propagation algorithm? And the main algorithm, the important algorithm used in neural network is back propagation algorithm. The name itself you can make it out back propagations. See, inputs are given in forward direction. If there is a error, the error will be back propagated in neural network. So, the ultimate aim is we need to get a solutions. So, during training time, the inputs are given from forward to from left to right, like it goes forward direction. If there is a error, it will come to backward direction, and this error helps to modify the weights. Let us see how it will work, back propagation algorithm. Look at this diagram. Here there are two inputs, x1, x2 are the two inputs, and this is input layer, this is hidden layer, this is output layer. Here input layer f1, f2, f3, there are 3 neurons, and hidden layer there are 2 neurons, f4, f5, and output layer 1 neuron. So, the output is y. Now, each neuron, see, look at the input is given to all the 3 neurons in the first line, x1, x1, 2 inputs, x1 is given to f1, f2 as well as f3. Then x2 is given to f1, f2, f3. The same way the output of this y1, this is called y1, output is y1. y1 is given to f4 as well as f5. y2 is given to f4, f5. y3 is given to f4, f5. Here y4 is given to f6. y5 is given to f6 and our final output. How it will work? First, the input is given to the input layer. Here f1, f2, f3 of E indicates the activation functions. Here input to this particular neuron is, this neuron is the x1 into wx1. The label for this link is wx1. You can say w11 also. First input, first link. This is w11. Here you can say this is w12, and this link you can say w13. The same way here x2 w21. You can say this is w22, w23. Let us see what could be the output of this neuron, this f1 neuron, y1. This is the output of this neuron, y1 equal to f1 wx1. This is weight into input plus, and this neuron gets input from the two inputs from the two variable x1, x2. So, w x21 into x2. This is the output of the neuron f1. The same way f2, if you see this color, different color, this blue color, y2 equal to y2 f2. This is function of wx12 into x1, w x22 into x2. This is the output of this second neuron. The same way output this third neuron, output of this third neuron is f3. This f3, this is x1 into w x13 plus x2 into w x23. This will be the output of y. If you apply the activation function on those sum of the weights, if you the product of input into weight and sum of the product of weights, if you apply the activation functions, you will get the actual output. So, the output of f1 is y1, this is y2, this is y3. So, now you got the output in the input layer. Then all this output will be given as a input to the next layer. Next layer we have only 2 neurons, f4 and f5. So, all the inputs are given to both neurons. Here also this neuron get all the 3 inputs and this neuron gets all the 3 input. Look at this diagram. Now, how will you calculate the output of this neuron f4, y4 equal to f4, that is activation function, w14, this is the weight, the link, this is connection from the first neuron, w14 into y1, the output of this, because the output of f1 will be the given input to the this neuron, plus, and another connection is here, w24 into y2 plus w34 into y3. These are the input to this neuron. Again the output of this neuron is y4. y4 is given to this. The same way it continues. Next y5 will also be, y5 will be calculated from the all the 3, f1, f2, f3. This is w15 into y1, w25 into y2 plus w35 into y3. And if you apply with this input activation function f5, you will get the output of this y5. Then finally this final output y equal to output from this, the output of this is y4, this is y5. So w46 into y4 plus W56 into Y5, this is whatever the Y we are getting, this is the actual output. But during this training system, we know what would be the output, that actual, that is called targeted output. So targeted output here it is called Z, targeted output is Z. So the difference between actual and target is a error, this is called, it's given in delta symbol, delta Z equal to Z, this is actual, this is targeted minus actual, it can be plus or minus, this is called error. So in back propagation, what it has to propagate the error backside. So that why this, what is the use of this error? This error will help to modify the weight, because to converge into the problem, only thing is in neural network you can keep on modifying the weight of the neuron, the weight of the connections, connection between neuron, each neuron each connection has a weight. If you keep on modify the weight, it will converge into the solutions. So the error, whatever the error we are getting in the output layer, that will be back propagated to first hidden layer, then input layer, then again once it reaches the input level, then that error will help to modify the weights. Look at this, this is delta, here the error is delta, this is actually propagated to the previous layer Y4, here delta 4, this is the error here equal to W4, this weight into that whatever the error amount we got it, this one. The same way here next, delta 5 equal to W56 into delta, and delta 1 equal to from previous layer W14, here this is connected with the 2, W14 into delta 4 plus W15 into delta 5. Here the same way, delta 2 is calculated equal, here look at this, delta 2 is calculated from delta 4 as well as delta 5, delta 4 into W, the relation 2 4 plus the here delta 2 plus W 2 5 into delta 5, like this we need to calculate. And after calculating delta 1, delta 2, delta 3, that is error rate, then this error rate will help to modify the weight. Previously there is weight has been initialized, so the weight should be modified. So the modified weight, this is new weight between the first new x1 to 11, W11 plus this theta, this theta is a constant, you can add jitter value or bias to just converge into the solution. Theta into delta 1, this error, this is called derivative of activation function, df1e divided by de into x1. This is the way, the lot of formulas are available to modify the weight. This is one of the delta rule, we can say this is a delta rule to modify the weight. The same way for second neuron W21, this is the weight, how it can be modified, W existing weight plus theta delta 1 and the derivation of the neuron activation function into x2. The same way for next layer we need to calculate, and finally all the weights have been modified. Again after modifying the weight, then we need to calculate the difference between the this actual output and targeted output. Again if you keep on modifying, at one point of time the difference between actual and targeted output will be less, at the time we need to stop the training. So more where this ANN are applied, it's in classification, modeling and control and forecasting, medical diagnosis, signature verification, modeling side in mechanical, electromechanical area also, for predicting, even for load prediction of this power, there also this can be very much useful. And because our topic is actually how it is helpful in medical domain. So now medical decision support is an area of increasing research interest. It supports doctors every day for making the decision, and this neural networks plays major role for clinical diagnosis as well as prognosis with the help of symptoms and signs. It assists it can't replace the doctor, but it can assist to make a decision. And there are some problems with the neural network. Neural network, you can't say it will all the time it will work pakka. There are some problems when actually for simple problem you cannot apply the neural network. If there is something cognitive related or intelligence required, there you can apply neural network, number one. Number two, when complexity of the problem is too much, then you need to have lot of layers, and for each layer lot of neurons are should be used. That means size will be increases. When size increases, suppose the neural network size, it has a number of layers increases, number of neurons in each layer increases, means again training time increases, training set size increases, classification time increases. So based on the nature of the applications, it has to use. Again, the main problem here, overfitting. If you keep on, see, iteration also, you need to stop at particular time when training error are being reduced, because for every iteration we are calculating the error. When training error is reduced, and if you apply the neural network validation data set, if it increases, that is the time to stop the training. If you don't stop, if you keep on training the neural network, after some time it start to memorize the things, mugging up the things. Mugging up again, instead of applying the intelligence, it's a kind of mugging up the things. Then that will create a problem. That problem is called overfitting. And sometimes if a neural network is an overfitting problem, it falls into local optima. What is that local optima? So it assumes that while training or testing, it assumes that is a correct solution point. The curve should follow that particular point. That is called local optima. So when complexity increases, instead of using neural network alone, we can use some other intelligence techniques, or we can to address the weakness of neural network. Either you can combine this neural network with either fuzzy logic or genetic algorithm. I'll go through fast how this can be helpful to solve. So mainly genetic algorithm, remove the problem of local optima. It provide the global optimal solutions. And fuzzy logic, instead of giving input as it is to the neural network, fuzzy logic it helps to represent the data in proper manner. I'll give one example why we need to include the fuzzy logic. Suppose in medical field there is one image, the image name called SPECT image. This image, by seeing the image, the system or should say it is whether it is normal or abnormal. So it's a cardiac image. So how this can be done? So let us assume that neural network, it has two output. One output is normal, one output, sorry, it has either one class is normal, another class is abnormal. Okay, suppose you are processing, you are giving the input, the output in the first normal output is 0.092 and the second abnormal output is 0.6. In this case, clearly you can declare it is output is normal, because this output is 0.92, which is higher than this 0.6. Both are extreme. This is 0.92, this is 0.16. You can declare this image is normal. If a neural network gives output like this, two outputs are there, one output is 0.92, another one is 0.16, means you can declare this is normal. And when this is normal, one second, this is normal, and we can conclude the risk of this is cardiac image, risk of heart attack is low. Suppose the normal output is low, 0.07, abnormal is 0.51. Here you can say it is abnormal. So in this case it is somewhat high. However, the two outputs are so close. One normal output is 0.51, abnormal is 0.49. So how can we make a decision whether it is this image gives normal or it is normal or abnormal? So it's very difficult to classify the image. So we need to use some other technique to classify the data properly. So fuzzy logic is one of the solutions to classify this data. Fuzzy logic is like, whereas in neural network it can accept both binary as well as but it is like two conditions. It can be either input can be 0 or 1. Suppose I have a pain in this leg. Do you have a pain? Yes means 1, no means 0. But it can be represented easily with the neural network. But how will you represent the in-between cases? Lightly, somewhat, or during rest, or sometimes, rarely. Like how will you represent all these things? So because each and every when you doctor ask where physician asks, you can say, you can't say all the time yes or no. You can say sometimes during rest I have pain, morning time I have pain, slightly when you pick up some object. So these things should be represented in the system to get a correct classification. That can be possible with the fuzzy logic. So it is used to represent the values between the 0 and 1. Neural network, it can represent 0 as well as 1. Fuzzy in between values to represent, it uses fuzzy logic can be used. Look at this. The previous we have a neural network 2 outputs. Instead of having the values, the same values 0 to 1 can be represented in the with the 3 linguistic variable. Low means 0 to 0.4 is low, and then medium is 0.2 to 0.6, and high is 0.6 to 1. The same way for abnormal input also we can have the graph. So for each, instead of giving the crisp value, we are giving the fuzzy value. It can be okay, it can be low, it can be medium, it can be high. If somebody says medium, it can be any value. It can be 0.2 to 0.8. The same way, the risk output can also be represented in this way. Instead of low high, you can have very low, low, moderate, high, very high. Only thing is that 0 and 100, it will be 0 to 25 is very low, 10 to 40 is low, and 25 to 20, sorry. This, look at this moderate starts at 25 and it is still 75 is moderate, 60 to 90 is high, and very high is 75 to 100 is very high. Like this, instead of representing the crisp value, you can represent in the form of fuzzy set. Then to just make a decision in which category it comes, you can say if NN output is low, these are called fuzzy rules. You can, with the help of fuzzy rules, you can make a decision in which category it comes. If NN output is low, NN output, second output is, both output is low, then risk is moderate. Instead of saying it is 0.16, it is 0.97, we can say it is low or medium. Instead of saying like this, you can convert everything into linguistic form. If NN output is medium and both output is medium, then risk is moderate. If one is high, both is high, you can say risk is moderate. If one is high, one is medium, low. Like this, we can, with the help of fuzzy set, if there is a uncertainty, imprecise data, you can with the help of fuzzy logic, we can make a decision. And finally, how genetic algorithm plays major role in that actually. This is the third part, genetic algorithm. This is also like artificial neural network, it also simulate the biological evolution. It simulates the behavior of biological evolution process, just simulates. So genetic algorithm, it has genetic algorithm, ES, EP and genetic programming. Our focus is genetic algorithm. It is the idea provided by the person called Alan Turing. Genetically or evolutionary search, it's mainly search technique. The genetic algorithm, how it will work instead of one solution, it will work with the pool of solutions and it picks up the best solutions. So wherever the complexity arises, wherever the optimization required, there you can have this GA, genetic algorithm technique. So to solve the problem which need optimization, it's based on Darwin theory of evolutions. So mainly when you compare to neural network has a problem of local optima that can be solved by this genetic algorithm. Here for genetic algorithm, no need to prior knowledge, because for neural network it should have prior knowledge. Here genetic algorithm only searching and optimization, so it's not required. So genetic algorithm works with the population of the solutions. Among that, it will take the best solutions. So it is mainly used for parallel processing. What is the genetic algorithm? It is an iterative procedures to a group of global optimization which are stochastic in nature and less prone to convergence to weak local minima. Suppose you are solving a particular problem with a neural network, you keep on training and sometimes you feel like you are not getting the correct solutions, all the time it falls in local optima, then you can combine that neural network with the genetic algorithm which will provide a good solutions. So before discussing, getting into the applications, some of the terms are required. Genetic algorithm. When you talk about genetic algorithm, it's a biological evolution process. It uses chromosomes. Chromosomes is nothing but a symbolic representation of a parameters. Each solution, suppose what are the possible solutions? All the possible solutions are represented in a form of a string. Each string is called chromosomes. Chromosomes can be a binary string, okay, and each bit in a chromosome is called gene. And these are the selection, these are the operators, genetic operators, selection, crossover, mutation, and this encoding techniques are how the for any application we can use the genetic algorithm, how the data can be encoded, whether the binary encoding or tree encoding, all this can be used with the encoding techniques. So how this genetic algorithm applied in this GA can be applied to the neural network? For selection of model, for input feature selection, for weight initialization, for modifying the connection weight between each node, for selecting the network topology, learning network parameters. As far as neural network is concerned, the main challenge is layers, how many network topology, how the weight can be optimized, how the input feature can be selected, because for any application you may give any number of inputs. Some of the inputs will not contribute anything, but instead of contributing, it just degrades the performance of the neural network. In that case, we need to identify which are the inputs are very important, which are the inputs should be given to converge into solution. For selecting such inputs, we can use the genetic algorithm. Again, before first time actually you have to initialize the weights. Initializing weight also there should be some logic. How the weights, you can randomly initialize and you can do experiment. In that case, genetic algorithm will help to initialize the weight, modify the weight, and to train the neural network. Apart from that, backpropagation algorithm are used to train the neural network. This is simple genetic algorithm. How the genetic start with a randomly generated population of n chromosomes. Generally, when you solve any problem, what are the possible solutions? What are the possible solutions? Each solution is called one chromosome. All the possible solutions are put together, that is called population. The n chromosome means n population will be there. From that we need to select the best solutions. Calculate the fitness of each chromosome. Here you need to, for each for a particular problem you can have n number of solutions. For example, for traveling salesman problem you can get n number of solutions. Whether all the solutions are efficient one? No. So we need to identify which solution will be efficient one. Even though it satisfies the constraint, you need to identify which solutions are efficient one. So you need to calculate the fitness for every chromosome based on the nature of application. There is a fitness function. The challenging task in the genetic algorithm is defining the fitness function. Once you define the fitness function, then easily you can identify the fittest chromosome. So calculate the fitness of each chromosome in X in the population. Then repeat the following steps until n offspring have been created. What do you mean by offspring? If you have one or two parent, you can create a child. That child is called here taking the offspring. So randomly select a pair of parent chromosome from the current population. Then cross over the pair at randomly chosen point to form two offspring, and randomly mutate the two offspring and add the resulting chromosomes. Calculate the fitness of the resulting chromosome. You have n number of population. If you do this process n time, at the end of nth time you will have the population which have the all chromosomes are the fittest chromosomes, and it will survive to the next generation. This is the concept behind biological evolution. So this is the operator. Selection is one of the operator. This selection operator just select the fittest chromosome. For it uses a fitness function. So fittest selection, there are a lot of algorithm for selecting. There are a lot of route wheel algorithm is there, tournament selection algorithm is there, ranking algorithms. Depends upon the application, you can select any one of the algorithm. Most popular algorithm is route wheel selections. Here suppose here in this population there are 8 individuals. All 8 individuals are put together, and you can spin this wheel, and at this point spin the wheel n times to select any individual. Suppose if you want to select 2 individuals, you have to spin the wheel 2 individuals. What are the individuals are coming near the point, that will be selected as a parent. From that offspring will be created. The same way tournament selection also is kind of race, and the highest fitness value, if you apply the fitness value for each chromosome, what are the highest value, that will be declared as a winner. Then the second highest will be the second parent. That will be helpful to create a children. And there is a problem in the trout wheel when the fitness value differ very much. If you want to select two parent, one parent fitness value is 0.15, another parent fitness value is 0.85, means too much difference. In that case, that route built algorithm will not be helpful. In the we have to go for rank selection. Rank selection here, the worst value worst value will be 1, 2, 3, 4. It will be, then the chromosome will have nth or 9th or 10th. If you have 10 chromosomes, 10th will be the highest if it is, 9th will be next highest. Like this, you need to select the parent. So this is next operator is crossover operator. Here look at this. This is 1 point. You have, this is one chromosome. After selection, you will get 2 chromosomes. This is parent 1, parent 2. Now you have to create a child. You need to, you can put cut at any point. Here we have put cut 2, 4, 6, 8, 9, 10th place we have put cut in both parent here. So the child will be created. This is first off will be taken and second off will be taken. This arrow indicates this will be taken, the first underline, this will be one child, and next child will be from here, this and this. This is called 1 point crossover because there is a 1 cut in this chromosome. If you go to next 2 point crossover, there is a 2 cut, 2 cuts are there. So how will you create here? You can create a 3 child. Here look at this, this will be taken first, second, third, this will be one child, and here 1, 2, 3, 2 child will be created. I will finish. Uniform crossover. You can put the first one bit will be taken from here, and next 2 bit will be taken from the parent one. Next 1 from here to here. Like this is uniform crossover. Like multiple crossover are available. And then mutation. To just to converge or to get more optimized solution, this mutation operator is nothing but a flipping the bit. If randomly you can select any offspring, just flip the bit. If it is 0, make it 1, or 1 make it 0, then you just check, maybe if it converges, that will be treated as a good solution. So why hybrid GANN? We have discussed already. There are a lot of weakness in neural networks. To address all this weakness, genetic algorithms are being used. This is one of the neurogenetic algorithm. I'll go to the directly to the applications. So this is one of the application. It uses a neurogenetic algorithm. So this is a prediction tool for stroke disease. Stroke is one of the life-threatening disease, and risk of stroke is greater and recovery process is low. The samples we have taken, 150 samples have been taken, and all the data sets are divided into 3: training set, validation set, and test set. And these are the for prediction. These are steps to be followed. One is feature selection. Second one is model selection, and third one is training, validating. Feature selection for this, there are a lot of these are there are 20 inputs. These are the symptoms. 20 inputs are given. If you give all the 20 inputs to the neural network, it will not. Sometimes it will not converge. Out of 20 inputs, some of the inputs will never contribute. Instead of contributing, it will degrade the performance of the system. So to avoid this, what we have to do? You need to select some important features. For selecting important features, we can use genetic algorithm to select the important features. What are the features? So for every new input, how much it plays into the converging solutions. What is the role? So input importance should be calculated. After that, model should be selected. Then after creating the model, it can be trained. So in this here, out of 150 samples, training set actually 104 samples are being used to train the neural network, and 25 validation, 16% validation, and 14% test, and pre-processing. When you give a data samples, you can give the data as it is. Some pre-processing is required. Why data pre-processing is? It's nothing but cleaning the data. There's some data, what are the outliers are there, what are the missing values, how the missing values can be substituted, how the outliers are removed, and how outliers are replaced. All these things can be done in the pre-processing. These are the input attributes as we discussed before. And feature subset. The main feature selection is to reduce the number of features. If you give all the, what are the features you are getting from the hospital or getting from anywhere, if you give all the features, it will not work. There is some pre-processing is required. For feature selection algorithm, we have used genetic algorithm. You can use genetic algorithm for feature selection also. Genetic algorithm, see this, look at this here. first initial count, fitness, number of cycles or fitness is 0, count is 0. Initial population, all the features, you need to create a solutions with all the features. Then with that features you have to design a suitable network and train the network with BP with the back propagation algorithm. Then find the error. If this error indicates the fitness value. If previous fitness is less than current, you have to do for every features you have to do. If the fitness previous fitness is less than fitness mean, then store the current value. If it is greater than means, you can go to the next level. If it is greater than means, then you have to apply the genetic operator, selection, crossover, mutation and reproduction, and this will be repeated for all the 20 features. After that, what was the output here? 14 features are selected out of 20 features. 14 features are really contributing to this problem. The remaining 6 features are not contributing anything, so it is removed. So after that, neural network. See here, this is called input layer. The second one is hidden layer, and the last one is here. This neural network has 10 outputs. It's a real-time problem. Here it classifies the 10 types of stroke disease. For that, it is given 14 inputs are given, 9 hidden layers. The network design. This also we need to design. Different topology can be designed. For that, you can use genetic algorithm, or you can give inputs and train the network, and based on that, best network topology can be selected. This is 14 input, 9 hidden layer, and finally 10 output. These two cannot be changed. The input and the output cannot be changed. Only hidden neurons will be changed. And here the genetic algorithm can be used in neural network for weight optimization. As I said, you can randomly allocate the weight and check whether it is towards solutions or whether it is moving away from the solution. Based on that, you can modify the weight, and you can use genetic algorithm, genetic operator also. Here also the same way. Assign weights for each link, computer hidden layer value, computer output layer, like how we have done. Then the fitness is less than means store current weight, otherwise next generation, and apply the all this operator, apply the 3 operator crossover. Now last one is testing process. After training, the next one is you have the test data also. You need to test the neural network with the testing process. So the output of testing process is confusion matrix. Confusion matrix is used to classify whether your model has been classified, to judge whether model has been classified correctly or not. Look at this here. There are 10 outputs, 10 classifications. A is left hemiplegia, TIA. These are the different kinds of stroke disease. So we have taken 150 samples, and most of the samples classified correctly. Look at this here. Here instead of this one, it should be supposed to be here in H. I think so. In H it should be in H. H is dysphagia. Instead of dysphagia, it is declared as a right hemiplegia, because if you see symptoms and sign, if you compare to for 2 diseases, the symptoms and sign looks same, but there is a minor difference. Sometimes this is called misclassification. So how to avoid misclassification? This will happen. Again, I am telling that this will not replace the doctor. This will help to assist or help to predict or assist the doctor. Compared to this neural network, see, neural network in medical field, it gives like 86 to 90% accuracy, but when you compare with the neural network with this, some other technique like fuzzy logic, genetic algorithm, there is a scope of giving the accuracy 96. Since medical field, we cannot compromise accuracy. Accuracy is more important. If you use only neural network, that will not be helpful. It can be combined with the fuzzy, neuro-fuzzy systems are there, or it can be combined with the genetic algorithm, neurogenetic algorithm, or neurogenetic fuzzy. See, the purpose of this is to develop a model for diagnosis or prediction of any disease. Whatever we discuss, this is this example. Apart from that, in this chapter, you should know what is soft computing components, what is neural network, what is fuzzy logic, what is genetic algorithm, how it can be applied to the real-time applications. I hope you understood everything, and with that, let me come to the conclusion. It is a computational techniques, and it's kind of it's derived from statistics. At the end of the course, I hope you'll be able to represent the knowledge, able to develop a model, and able to apply this model for any real-time application. Thank you.